Welcome to Decoding Healthcare Research. I'm your host, Efrain Riveros, Dr. E.F. Rain. We have been developing several topics. One of them is nutrition. Nutrition is critical for different aspects of our life. It's easy to understand that when a pathological process develops, before that happens, there are some changes at the biochemical level, and before that, there are some other changes at the genetic and epigenetic level. So it's important the role of metabolism in any pathological process. For me, it's clear that when you have a normal metabolism, that metabolism translates into a normal metabolism at the cellular level as well. And the central nervous system is not the exception. In other words, we can say that if you have a balanced metabolism systemically, you are going to have a balanced metabolism in your brain. There are several examples for this balance that can be disrupted in pathological cases. One of them is Alzheimer's disease. Today we have the privilege of discussing this topic with Dr. Perlmutter. He's going to illustrate several points that are critical to understand the pathogenesis of the disease. And the situation goes even beyond Alzheimer's disease. So that connection between systemic metabolism and brain metabolism has several points in which it can be disrupted. We can say that any metabolic disruption that leads to an increase in the production of fructose by the liver leads to several ramifications, one of them being the increased production of uric acid that stimulates oxidative stress at the level of the mitochondria. And this can have, as a consequence, different alterations in cells systemically, but in neurons in particular. So we are going to talk about the survival switch that has fructose at the very center, and we will correlate this survival switch with what happens in Alzheimer's disease. I want you to pay attention to one important aspect that Dr. Perlmutter is always emphasizing, that you don't have to wait until an old age to start trying to prevent disease. Actually, disease is a continuum that starts from a younger age. So it's probably important for the younger generations to pay attention to their metabolism and how nutrition affects that metabolism, so that you might maintain a healthy continuum between the systemic metabolism and the central nervous system metabolism. Because in the end, what is the goal? To have a happy life in the future. And for that, you need a functioning cognitive executive brain. So I hope you guys enjoy this episode with Dr. Perlmutter. Welcome to Decoding Healthcare Research. I'm your host, Efrain Riveros, Dr. E.F. Rain. Today we are going to talk about Alzheimer's disease, metabolism and Alzheimer's disease, a new paradigm. And for that we have a well-renowned expert. I would say the most important person we could have to talk about this topic, and is Dr. David Perlmutter. He's a board-certified neurologist, associate professor, University of Miami Miller School of Medicine, fellow of the American College of Nutrition, and six-time New York Times best-selling author. I am sure that everybody knows who he is, but I just needed to make the initial introduction. So welcome, Dr. Perlmutter.
I'm delighted to be with you today. Thank you for having me.
Thank you so much. So we are going to talk about a paper that Dr. Perlmutter and his team published in the American Journal of Clinical Nutrition this year. The title of the paper is Could Alzheimer's Disease Be a Maladaptation of an Evolutionary Survival Pathway Mediated by Intracerebral Fructose and Uric Acid Metabolism? So Alzheimer's disease, we all know, is a huge public health problem. More than 50 million people are affected, and that's not counting those with mild cognitive dysfunction, and it's even underdiagnosed, and it's even at the top of the mortality causes in the Western world. The metabolism is definitely in the pathway that leads to Alzheimer's disease. And my first question to Dr. Perlmutter is, where is the link between sugar metabolism and Alzheimer's disease?
Let's begin by talking about what metabolism, what does that word even mean? Because I think it's fundamental as we then develop the thesis today that metabolism or problems with metabolism relate to the brain. Metabolism basically describes how our cells utilize fuel to carry out their day-to-day tasks of what cells do. And in the case of brain cells, that would be transmission of information. And so what we're talking about then is how do brain cells use fuel, in this case glucose primarily, to carry out their activities. And, the brain is a very active organ. The brain only weighs 2 to 3% of the total body weight, and yet at rest it's consuming about 20% of the body's energy. So it's really very demanding of energy. And so as such, when that is compromised, when the brain is not doing it well enough, we begin to see the brain start to decline in terms of its function and ultimately fail to the extent that the actual cells themselves cannot survive and begin to fall out and fade. And this is a central event as it relates to the development of Alzheimer's disease that you quite well characterized is a global epidemic with far greater implications than infectious issues, for example, like COVID. We've really got to pay attention. You mentioned 50 million, probably closer to 55 million people a year, people affected by it, but 10 million a year are newly diagnosed with this disease for which we have no meaningful treatment. Now, many people have seen headlines over the past 1 year that suddenly there are at least 3 new wonderful Alzheimer's drugs that are becoming available. And the reality is that there's a variety of problems with this realization. First, these drugs are only described to be effective or rather useful in only about 5% of Alzheimer's patients, leaving 95% of Alzheimer's patients out in the cold as it relates to their ability to have access to a medicine that might help them. The second thing that's very challenging for those of us involved in this type of work is that the medicines don't really work very well at all. Their effectiveness at the 18-month point, which is when they're generally evaluated, is very minimal in comparison to placebo in terms of how patients are after 18 months. The third thing is they're not without risk. We see the development in about 15% of people of something called ARIA, which means amyloid-related imaging abnormalities, basically small hemorrhages or bleeding into the brain in comparison to those who didn't receive the actual medication. So I'm not opposed to the development of an Alzheimer's drug. I would absolutely welcome it. We aren't there yet. So we have to do whatever we can to focus on preventing the disease in the first place. And we know that to a great degree, we can accomplish that task. Desmond Tutu once said that while it's important to take people out of the river, it's actually much more important to ask why they're falling in the river in the first place. And that's what I believe applies to our approach to Alzheimer's. Right now, we're focusing on trying to pull people out of the river, but in my world, I think it's far more valuable to ask why people are falling in the first place. That's what prevention is all about. And, our world is really very much embracing the notion of preventing cardiovascular disease, keeping people from having heart attacks, keeping people or reducing their risk of stroke by controlling their blood pressure. And the notion of preventing Alzheimer's needs to gain some traction. We're actually in the formative stages of creating Alzheimer's Global Prevention Day, which will happen on May 15th, 2024. We already see Alzheimer's Awareness Week. Well, you know what? That's all well and good. We're aware of Alzheimer's, but we need to prevent it. We need to get the word out that prior to the development of this particular protein that you mentioned, beta amyloid, that is the target of all the new drug therapies, what's going on before that even happens? And, parenthetically, I'll just state that there are plenty of patients that develop Alzheimer's disease who don't have an abnormal accumulation of this protein in their brains, beta amyloid, number one. And number two, there are plenty of individuals who develop a large amount of amyloid in the brain and don't get Alzheimer's. So the notion that it is, the cause of Alzheimer's disease, I think needs to be reevaluated. To be fair, and I'll characterize this as being my opinion, it seems clear that the reason medical science seems so focused on this protein is because we're now seeing the development of specific therapies geared at that protein that have great value to the developers of these drugs. Let's be clear, they don't really work, and they're only indicated for about 5% of Alzheimer's patients, as I mentioned earlier. So let's ask ourselves then, what's upstream? Why are people falling into the water? What's going on with them that ultimately sets the stage for this globally pervasive situation, Alzheimer's disease, that, as you well characterized, is a significant cause of mortality? In other words, it kills people. Here in America, it's ranked as the third leading cause of death. Think about that. And what's going on is that the brain's metabolism is changing. And that gets back to how we started our conversation today, when we unpacked what is metabolism, that the brain is a very metabolically hungry organ. So because it requires so much energy, you'd think that that's an opportunity for there to be problems, and it is. The brain requires an awful lot of juice going into it in terms of energy. So any fluctuation in the brain's ability to use energy could manifest as a problem. And indeed, that's what's upstream. That's why people are falling into the water as it relates to the risk for and ultimately the development of Alzheimer's disease. In the Journal of the American Medical Association back in 2020 was an interesting article that was described in Alzheimer's disease, glucose metabolism takes center stage. Profound article, editorial, that really focused on the notion that what makes a good brain go bad are problems with metabolism, problem with its ability to use fuel as a fuel source. It's the same thing that's involved in why people become insulin resistant and paves the way for them to become diabetic. So we really have to focus our efforts on helping people regain good metabolism if we're going to be able to help reduce their risk for developing this disease for which there is no pharmaceutical treatment that has merit.
And it's interesting that when we talk about metabolism, I would say we have the metabolism of the brain cell. We also have systemic metabolism, and they are interconnected. So I want our discussion to start in the neuron. So we know that in Alzheimer's disease, the neuron starts using less glucose, which is kind of counterintuitive, and there is mitochondrial dysfunction. So those are still consequences of something that comes wrong from the systemic standpoint. So can you guide us through that pathway from the systemic to the brain?
Of course. And I think that we've all fallen into a place that is perhaps a little bit less valuable anymore, of looking at one hand in terms of systemic metabolism, and then on the other hand, looking at central or brain-related metabolism, because the reality is they're one and the same. The body is an integrated whole. What affects the liver, the heart, the kidneys affects the brain. What affects the brain affects the entire rest of the body. It's not disparate. It's not a functioning system in and of itself. And that's really, really very, very important because, people say, well, I'm on a heart smart diet because that's what my doctor told me I should be doing because the science shows that eating in a certain way is good for my heart, helps reduce cardiovascular disease. How could there be a heart smart diet that might not be good for another part of the body? How would there be a diet that's good for my immune system that wouldn't be good for me elsewhere in my body? When we understand that the body responds to its environment, and when I say its environment, that means, sure, the things that we're exposed to externally, but our foods as well. Our environment includes modifiable factors, the foods we eat, the sleep we get, the exercise we get, the stress to which we are exposed, the purity of the air and water that we are exposed to and we consume. These are all considered environmental factors that play upon, then, our DNA, our genetic or our inherited factors, risks, the way our genome has been modified over countless generations to keep us healthy and allow us to reproduce. And for so long, there has been this dichotomy between nature and nurture, nature being our DNA and nurture being those factors that influence us, like our diet and our sleep and our stress, etc. But we now recognize that the things to which we are exposed and choose to expose ourselves to play upon our DNA, influence the expression of our DNA, which in turn influences how we are affected by the things in our environment to which we are exposed. So rather than this dichotomy between nature and nurture, that you're either one or the other, there's a dance, a beautiful dance, and that the music to which our nature and nurture dance to has been refined over millions of years to get us to the point where ideally our DNA, our genome will respond wonderfully to our environment and we will live a long and healthy life. And that's how it's been until a blink of an eye ago, until just recently when suddenly the tables were turned and we suddenly had a dramatic shift in the foods that we eat, in the stress that we are exposed to, the environment, the air pollution, the polluted water, etc., the lack of sleep, lack of restorative sleep that so characterizes the world in which we live. So having said that, these are then the stresses that are put upon our systemic bodies by our environment, by the foods that we eat. And when I say that, I'm including the brain, such that the foods that we eat, for example, change the function of our gut bacteria, our microbiome, and that sets the stage for changes in our metabolism, changes in the way that we regulate our blood sugar, changes in the way that our insulin works to keep our blood sugar under control. Make no mistake about it, this affects the brain as well. We're now hearing many talk about the so-called gut-brain connection, which is one-sided. It should be the gut-brain and brain-gut connection, to be fair. But the microbiome, the gut bacteria, the viruses, the fungi, and their metabolic products and their DNA and RNA affect the brain, that's for sure, affect the entire body, regulates blood sugar in the body, and regulates how sugar works in the brain as well. So it's an artificial dichotomy then between the systemic health and physiology and the brain health and physiology. They are one and the same. When we become insulin resistant, when our blood sugars rise, when insulin is less effective in the body, it has similar effects within the brain and sets the stage for the neurons to fail. It sets the stage for compromising, as you mentioned, the function of the mitochondria to produce energy, to produce ATP. And this is powerfully threatening to the brain cells because they are indeed so energy dependent. And when the mitochondria begin to fail, we focus on the energy productive capacity of mitochondria. We learn in high school biology class that the mitochondria are the energy powerhouses of the cell, but the reality is they do a lot more. And one of their important functions is the mitochondria decide ultimately whether a brain cell will live or die. When mitochondria ultimately become compromised and brain cell energetics are compromised, it sets into motion a cascade of events that signals what is called neuronal apoptosis, where a mechanism is activated that kills the brain cell. And that brain cell is gone, never to return. What sets the stage for that, or to use our metaphor from earlier in our discussion, what is upstream of that is energy deficiency in that cell, brought on by things affecting the gut bacteria, by things affecting the gut through other pathways that affect the body, that sets the stage for insulin resistance through dietary indiscretion, dietary changes, or the modern diet, if you will. So it takes a little bit of thought to connect all of these. And ultimately, what we came to realize in writing the paper that you referred to is that Alzheimer's may be a manifestation of a very highly conserved primitive defense mechanism in the human body that allows our body to go into or the brain to go into a certain type of behavior that might have allowed our ancestors to survive. A bit complicated, but increasing the level of fructose in the brain, both by dietary means, by eating a lot of fructose, but also by activating pathways in the brain that produce fructose, ultimately turns on inflammation in the body, inflammation in the brain that changes human behavior to allow us to take more risks, and as such might have allowed our ancestors, because they would take greater risks, to find food and survive. These days, activation of that pathway is maladaptive because it's leading us to consume more sugar, increasing inflammation, threatening the brain, and leading to insulin resistance, which sets the stage for these metabolic issues in the brain that presage the development of Alzheimer's by 20 to 30 years. Now, what I just said was that the metabolic changes that occur in the brain that set the stage for Alzheimer's occur 20 to 30 years before we become forgetful, before we ultimately go to the neurologist and say, I can't remember my grandchildren's names or whatever it may be. These changes begin and are metabolic changes occurring within the brain 20 to 30 years ahead of time, meaning that these discussions should be had with people in their 20s, 30s, and 40s in order to prevent Alzheimer's disease. And they are discussions centered on keeping our metabolism function optimally.
And you mentioned the fructose as one important player here. Not only the fructose that you consume in the diet, but even from glucose via sorbitol. But people usually ask, if fructose is not good, should I stop eating fruit? Because we know that fruits are full of fructose. What is the answer to that?
Well, there are actually several answers, and we'll go through them. First, fruit, despite the name fructose coming from fruit sugar, fruit is actually not that high in fructose. There may be, in a good-sized apple, for example, 5 grams of sugar, not all of which is fructose. And you compare that to 36 grams of sugar in a can of soda. That's where the problem is. It's not eating the apple. It's the soft drinks. And surprisingly, the fruit juices, that a 12-ounce glass of orange juice has the same amount of sugar as a 12 or ounce for ounce amount of sugar as you'll find in drinking a soda. So drinking a 16-ounce glass of your favorite soft drink or drinking orange juice or apple juice, you're getting the same amount of sugar, number one. Number two, the delivery of that small amount of sugar in fruit is accompanied by fiber, which slows the fructose absorption and therefore allows it to be processed and handled in the small intestine, doesn't allow it to saturate that small intestine to the extent that any fructose of any meaning will get to the liver where the trouble begins. Number three, the delivery of that fructose in a whole fruit is accompanied by things like vitamin C, that is helpful in terms of excretion of uric acid. We'll get to that in a moment, as well as various bioflavonoids that are also helpful in the metabolism of fructose such that it is not as threatening. You don't get that when you drink a can of ginger ale or soda. So I think the context and the amount of fructose are very important. I would say to you, Ephraim, that this is a question I'm oftentimes asked, and let's just unpack this a little bit further. The downstream consequence of eating a lot of or drinking a lot of fructose is ultimately it is metabolized into something called uric acid. Now, most people consider uric acid in the context of gout. If my uric acid level is high, I might get gout, my toes are going to hurt, et cetera, and that's true. But long before that happens, we've identified uric acid as being a powerful metabolic signal, basically telling your body to make and store fat to prepare for winter, to prepare for a time of food scarcity. So uric acid has been in primates for at least the past 8 million years a signal to the body to prepare for food scarcity. And we'll have to unpack that whole mechanism and that part of evolution maybe at another time. But uric acid then is far more important than simply being a player in the whole discussion of gout. Uric acid tells the body to make fat. It tells the body to store fat. It tells the body to increase glucose production in the liver. It tells the body to become insulin resistant, and it also damages the way mitochondria function. The reason it does that is because when the mitochondria are less active, we burn less energy, so we might survive. Well, most of us in the modern world are not in that situation where we need to damage our mitochondria in order to survive. Damaging our mitochondria is about the last thing that we should be wanting to do, because we've already discussed that. The brain is highly dependent on mitochondrial function for its survival and for its resistance to Alzheimer's disease. Fructose that you just brought up is metabolized to this powerful signal called uric acid that damages mitochondrial function. So it is for this reason that we've got to be very, very careful with the amount of fructose that we consume. And I will assure you that it goes well beyond the soft drinks and fruit juice. That in America, 60 to 70% of foods that are packaged have added sweetener. And by and large, these sweeteners are derived from high fructose corn syrup because it's very, very sweet and it's very, very inexpensive. So we are exposing ourselves to the sauces and condiments and the various foods that are packaged that we eat day in and day out to pretty high levels of fructose, the likes of which this human body has never been exposed to. And therefore we come back against this conundrum then, this dichotomy between our nature and our nurture. Our genome, our DNA wants us to be helpful, but our DNA expects a lot less fructose, or at least fructose maybe once a year at a time when we need to create more body fat to prepare for winter, not 365 days a year.
So we could say that an evolutionary adaptation started playing against us, right? Because we don't have the the machinery to deal with that, and because probably we don't really need we don't need that mechanism, as you say, in the
Yes,
majority of cases.
it's what we call an environmental evolutionary mismatch. And you probably caught me smiling. And the reason I smiled is because I wrote my first paper on this topic when I was 15, and it was published in our local newspaper. I had just come back from a car race, and it was loud, and it was polluted, and it was an awful environment. And I began to wonder back then about our bodies being able to adapt to that type of environment, which really characterizes the world now. It's loud, it's polluted, we don't sleep, we eat these foods. And I posed the question back then, the evolution goes at such a slow rate that the changes in our genome aren't going to be protective this time around. So the real call then is to change our environment and recognize that we play upon our DNA based upon the choices that we make every single day. And the fact that here I was thinking about it in, I don't know, I guess here I was in middle school, I guess, or probably maybe high school at that point. And to this day, it's been something I've been thinking about my entire life. So 50 plus years later.
Yeah, it's interesting how the approach is changing, and it's very valuable that it changes, because the old approach was not working, at least when we talk about Alzheimer's. And my next question has to do with the prescriptive part. So we know that these evolutionary pathways, the switch that we are talking about, is causing more harm than benefit. What should we do to turn it off and try to restore the normal pathway so that the brain is healthy?
So the switch, I'm going to be for all of your listeners who, really enjoy the science part of it. I'm going to just describe the switch, and then we'll talk about what we can do to influence the switch. The switch gets back to uric acid. When we have a high uric acid, we change metabolism. We go down a certain pathway that's bad. This pathway, when the switch is on, is one that amplifies fat production. It increases blood sugar, it raises blood pressure, it compromises insulin functionality, and it threatens our mitochondria. Now, the pathway has to do with how a certain molecule is dealt with or metabolized. A molecule is called AMP, adenosine monophosphate. It's actually very active in the energy currency discussion. Now, this AMP can go down one of two pathways. It can be taken care of by something called AMPK or AMP deaminase. Now, when it goes through AMPK, I think I'm telling you that because I think some of your listeners may have heard of AMP kinase, some of your viewers. And when AMPK is active, then it lowers our blood sugar. It increases the production of new wonderful mitochondria. It helps us burn our body fat and reduces our production of body fat. Who wouldn't want that? But if AMP is metabolized through its evil twin, which is AMP deaminase, it increases our body fat. It reduces our ability to use fat as energy, damages our mitochondria, and increases our blood sugar and our blood pressure. So we want to keep AMPK active, and we want to shut down its evil twin, AMP deaminase. And at the apex, whether we're going to go down AMP kinase or AMP deaminase, the evil twin, is uric acid. When uric acid is elevated, the evil twin takes over. We make more fat, we make more blood sugar, raise blood pressure, all these bad things when uric acid is elevated. And that's why we have to keep uric acid low. And what is the biggest input into formation of uric acid? Fructose. Drinking those sodas, eating those foods that have been sweetened. That's why we get into such trouble with our body fat and with our blood sugars, and the millions and tens of millions of people here in America with diabetes or prediabetes. The global epidemic of obesity is really centrally caused by this switch of changing where AMP is metabolized. Now, we want to keep AMPK active. AMPK is our friend. That's the good twin, if you will. And the ways that we activate AMPK include, number one, you guessed it, keeping the uric acid level low by reducing our fructose consumption. But we can activate AMPK in other ways. We can, one of the most powerful activators of AMPK is exercise. Who knew? That's why exercise is associated with better insulin function, lower blood sugar, more consumption of body fat, less formation of body fat. When you activate AMPK, it tells your entire body the hunting is good. In other words, we don't have to worry about food, so we don't have to store fat for energy. That's why we want to activate AMPK. We can activate it with physical exercise. We can activate it by taking various nutritional supplements, for example, like one called quercetin, which is available, I guess, worldwide. This helps to activate AMPK. Activation of AMPK is how certain diabetes drugs actually work, like metformin, for example, and the nutritional supplement, the herb berberine, acts to activate AMPK. So this is the switch that you questioned, the switch between having a really good functional metabolism, keeping us lean, burning fat for energy, keeping our mitochondria healthy, keeping our blood sugar low, keeping our blood pressure low. All of those metabolic parameters that, when they're working appropriately, help us keep our brains healthy and really extend our lifespan.
Yeah, and I think the main value of approaching the problem from the metabolic standpoint, where the uric acid is central in the context of the switch, it also gives us hope, because at the same, we know that this is going in the wrong direction, but at the same time, it's in our hands to change the course of progression of the disease, and actually prevent it, even if your genes are predisposing you to have it. Making some adaptations to your lifestyle, improving the quality of the food that you eat, doing some exercise, you are actually having in your own hands the solution, right?
That's right. You use the word hope, and I'm all in as it relates to hope, but I prefer to characterize what we are talking about right now as empowerment, meaning you got the information now you got to do it. So you sit around hoping that these changes happen, but it's the action that really is going to bring this about. And it is, really centered on dietary change, beginning to exercise if you aren't, or if you are exercising, maybe ratcheting up a little bit depending on what you're already doing. And not to underestimate the incredible importance of getting enough restorative sleep. We sleep, or should sleep, a third of our lives. 8 hours a day should be spent doing this activity that some people think is a waste of time. It is so incredibly central to our metabolic health, so that we've got to really emphasize that for people.
Absolutely, absolutely. So it's a multifaceted approach. And here we are talking about Alzheimer's disease, but I think everything is connected through inflammation, insulin resistance. So you might easily find the key to different illnesses, to prevention of those, and even to restoration of health when you are affected by one of those. That's for sure. And I want to wrap up our conversation, thanking you for being here with us, and
My pleasure.
The way you presented the metabolic pathways is actually very enjoyable for all of us. I'm super happy learning here from you, and this comparison that you did about the evil twins in terms of AMPK and the aminase is very illustrative, and I think everybody is going to get the message. Thank you, Dr. Perlmutter, for being here with us, sharing your wisdom and your knowledge.
Well, thank you so much for having me today, and I wish you all the best.
Thank you. So for our audience, you will find the link to the paper in the comment section. Also, don't forget to leave us your feedback about this podcast. See you in the next episode.